So highlight that there, and that's not the greatest picture because I don't actually have a highlighter on here, but that's the best I could do. The derivative of a function is a formula for the slope of a tangent line to a function at any point x. The process of taking the derivative is called differentiation. So I think I've said differentiation in here before, and y'all asked me what it was. This is what this is differentiation and integration are the two main or biggest topics in calculus. Limits, which we've already talked about a little bit. All right. So we're going to define the derivative as a limit. Now, there will be a very easy way to do derivatives. This first way is not so much fun and it's kind of long, but there's 1 to 2 questions on the AP test like this, and they're not hard. It's all the long way around to find the limit. To find the derivative, not the limit. You have to use the limit to find the derivative, and we go the long way around, but we don't really want to do that every time. But you've got to know how to do it so you can answer these 2 questions that are really easy on the AP test. So my first step is to take the function and plug in x plus h everywhere there's an x. Does anybody not understand what I did right here? I took this function, and because that's what the formula says, I plug in x plus h for x. Because that's what function notation means. If I have f of 3, I plug in 3 to the function. Does that make sense to y'all? Y'all remember that? Should be x plus h. Okay. So now the next part in my formula is subtracting f of x. So all f of x is this right here. It tells me what it is. F of x is just that. So minus, I'm going to put it in brackets because since it's minus, I'm going to have to distribute that minus sign out to everything. So like, let's do it in black. So, do what? Okay. So that's going to be x squared minus 3x plus 1. And everything is over h. So if I FOIL, I've still got the limit of h approaches 0. If I FOIL that part, x plus h, if I FOIL that out, get x squared plus 2xh plus h squared. Then the next part is distributing this negative 3 out to the x and the h. So that's minus 3x minus 3h. Because when I distribute a negative, it goes to both of them. So that's why they're both negative. Alright, so because this is a long problem. Alright, so then I've got the plus 1. Then I need to distribute the negative, this negative sign out to all 3 of those. So that's going to give me negative x squared plus 3x plus or minus 1. Sorry. And everything's over h. So now we've got to go back through and combine like terms. I've got a positive x squared and a negative x squared. Those will cancel out. I've got a positive 3x and a negative 3x. Those will cancel out. Positive and negative 1, those cancel out.
So we just canceled out the whole left side of that, or whole right side of that problem.
Yes, pretty much. And most of the time, something like that's going to happen.
What a waste of ink.
I know. But you've got to make sure you do it correctly. So I'm left with 2xh plus h squared minus 3h. Does that get everything on the top? I think so. All over h. then I know that it's going to be hard. This is where you probably need another piece of paper to kind of stick in right here, unless you can squeeze it all into that little bitty space. Of course, y'all can write smaller than I can on this thing. If we try to evaluate the limit here as, this should be h, not x, because we're looking at the h, we're not looking at x. So if I plug in 0 for h's, I'm just going to get 0 over 0, because all three of these would be 0, and this is 0, so 0 over 0. Does everybody see that? So if I get 0 over 0, that means I need to factor or something. So what I could do is pull out an h, as Levi said. That would give me h, then 2x plus h minus 3. Undo. Minus 3 all over h. Does anybody have any questions on what I did there?
Okay, we can just cancel the H.
So now our h's cancel, and we have the limit as h approaches 0 of 2x plus h minus 3. So now if we plug in 0, I've got 2x plus 0 minus 3, which is just 2x minus 3. So that's my limit. For notation of derivative, if I want the derivative of f of x, I don't want to write an equal sign. The derivative of f of x I could write as f prime of x. That's what that sign means. F prime of x. The little dash up there at the top. It just means prime. So when I say f prime of x, that's what I'm talking about. So I could write it that way. Or sometimes, like if you just have a function f, they'll say f prime. That's the derivative. If it's y equals some function, then what do you think it's going to be? Y prime. The only thing that it happens a lot, especially when we do differential equations towards the end, when you have to do differential equations. Another thing that it'll use is dy dx, or I think that's the only one it tells you. Okay, it didn't tell you the other ones. So dy dx also could be the derivative of y. All that means is the derivative of y with respect to x. That's what that means. And you just say it dy dx. It's not dy over dx, it's just dy dx. Does that make sense? So in the problem that we were just doing, we had f of x. So f prime of x is equal to 2x minus 3. So over here, we want to find that at 2, 0, and negative 1. We want to find the slope of the tangent line at 2, 0, and negative 1. So we need to find f prime of 2, f prime of 0, and f prime of negative 1. And all that means is I just plug that into the derivative I have. So that's 2 times 2 minus 3, which is 1. And that's 2 times 0 minus 3, which is negative 3. And then it's 2 times negative 1 minus 3, which is negative 5. So f of 2 is 1. f prime of 2 is 1. F prime of 0 is negative 3. And f prime of negative 1 is negative 5. So that's one problem. We'll practice these